Okay, my dear children, in the previous classes you have studied or you have learnt these types of relations. Just to let us recall these types of relations. What are they? First one is empty relation, and second one is universal relation. Third one is reflexive relation. Fourth one is a symmetric relation, and fifth one is a transitive relation. You have learned all these types of relations in the previous class. Now we are going to discuss about this last type of relation, that is equivalence relation. Okay, my dear children. Okay, my dear children. Now we define the equivalence relation. What is meant by equivalence relation? What is the definition of equivalence relation? Okay, a relation or in a set. A relation or in a set A is said to be an equivalence relation. Okay, a relation or in a set A is said to be an equivalence relation if R is reflexive, symmetric and transitive. If a relation R is reflexive, symmetric and transitive, then the relation is said to be an equivalence relation. Okay, my dear children. Now let us take an example for an equivalence relation. To understand this point, let us take an example. Okay, my dear children. See here, example. Let the relation R in the set A, the relation R in the set A is equal to set of all x belongs to Z such that 0 less than or equal to x less than or equal to 12. This is the given set A. Okay, and given by R is equal to set of all ordered pairs A comma B such that modulus of A minus B is a multiple of 4. This is the given relation. Okay, my dear children, this is the given set A and this is the given relation R. Right. Then we have to show that the relation R is an equivalence relation. Okay, my dear children. Now let us recollect the definition of an equivalence relation. What is the definition of an equivalence relation? When the relation R is said to be equivalence relation, if the relation R is reflexive, symmetric and transitive, then the relation R is said to be equivalence relation. Okay, my dear children, right. Now, to prove the relation R is an equivalence relation, we have to prove that relation R is reflexive relation, symmetric relation and transitive relation, right. Now we are going to prove the relation R is reflexive, symmetric and transitive relation step by step. Okay, my dear children. So to prove that reflexive relation, first let us take the given set. What is the given set A? A is equal to set of all such x such that x belongs to Z, 0 less than or equal to x less than or equal to 12. This is the given set. Since it is a finite set, let us write the elements of the set A. What the elements of set A? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the elements of the set A. Because it is a finite set, we wrote the elements of the set A. And the relation or the relation in the set A is given by R is equal to set of all ordered pairs A comma B such that modulus of A minus B is a multiple of 4. This is the given relation. Okay, my dear children, right. Now let us take one and only one element, namely A belongs to A. Let us take an element A belongs to A. Okay, now let us rewrite the given statement, rewrite the given relation. The given relation, just to replace A and B by A and A only. It means we get this statement, modulus of A minus A is equal to 0 is a multiple of 4. If you rewrite the given relation by replacing A and B by A and A, so we write this statement, we get this statement. Then we have to check whether this statement is true or false. True or false? Yes, true. Then we can say that the relation R is a reflexive. We can say that ordered pair A comma A belongs to R. means there are two elements A and A are satisfying the given relation. Therefore, we can say that R is a reflexive relation. Understood, my dear children? Now we are going to prove the relation R is a symmetric relation. We are going to prove that the relation R is a symmetric relation. Right. Let us take two elements, namely A comma B belongs to A. Let us take any two elements, namely A comma B belongs to A, and assume that ordered pair A comma B belongs to R. We are assuming that ordered pair A comma B belongs to R. It means the elements A and B are satisfying the given relation. So I wrote that relation here. Modulus of A minus B is a multiple of 4. What is meant by the statement? We can write this statement in the form of an equation like this: modulus of A minus B is equal to 4k, where k belongs to z. This implies if you remove modulus symbol, we get here the equation as A minus B is equal to plus or minus 4k, because we know that modulus of x is equal to plus or minus x. Okay, my dear children. Now this implies that if you multiply this equation by minus on both sides, we get b minus a is equal to minus r plus 4k. Okay, again this equation can be written in the form of statement like this. This implies modulus of b minus a is a multiple of 4. Okay, my dear children. This implies that we can write like this: ordered pair B comma A belongs to R, because the elements B and A also satisfying the given relation. Therefore, here we observe that if ordered pair A comma B belongs to R, implies that ordered pair B comma A belongs to R for all A comma B belongs to A. Okay, therefore we can say that the relation R is a symmetric relation. Okay, my dear children, here we have proved that the relation R is a symmetric relation. Next, we are going to prove that the relation R is a transitive relation. To prove this relation, we let us take three elements, not two elements. In the case of reflexive, we have taken only one element from the set A. In the case of symmetric, we have taken only two elements from the set A. And in the case of transitive relation, we take any three elements, namely A comma B comma C belongs to A. Okay, and we assume that ordered pair A comma B belongs to R and ordered pair B comma C belongs to R. Understood? We have taken any three elements to prove that transitive relation. We have taken any three elements from the set A, and we assumed that ordered pair A comma B belongs to R, means elements A and B are satisfying the given relation, and similarly ordered pair B comma C belongs to R. It means elements B and C are also satisfying the given relation R. Therefore, from this statement, ordered pair A comma B belongs to R implies that we can write relation between A and B in the form of statement like this: modulus of A minus B is a multiple of 4. Therefore, we can write like this: modulus of A minus B is equal to 4m for m belongs to Z. Understood, my dear children? I wrote the given statement in the form of an equation. This implies A minus B is equal to plus or minus 4m. This is the first equation. Let us consider this equation is equation 1. Because here modulus of x is equal to plus or minus x, we used this property. Similarly, we assumed that ordered pair B comma C also belongs to R. Ordered pair B comma C belongs to R implies, how can we write this relation between B and C? Modulus of B minus C is a multiple of 4, isn't it? Now we write this statement in the form of an equation as we wrote in the equation 1. Here therefore B minus C, modulus of B minus C is equal to 4n for some n belongs to Z. Okay, my dear children. Now just by removing the modulus symbol, then we get B minus C is equal to plus or minus 4n, because modulus of x is equal to plus or minus x. You know this property. Now consider this is equation 2. We got here equation 1 and here we got equation 2. Now by adding these two equations, we get in LHS A minus B plus B minus C is equal to plus or minus 4m plus or minus 4n. Isn't it? We get this equation. Now by simplifying this equation, in LHS we get a minus c is equal to, in LHS we get a minus c is equal to, if you taken out the common factor 4, if you observe that 4 is a common factor for these two terms. So if you are taken out this common factor 4 outside, then we get m plus n, plus or minus 4 of m plus n. This implies a minus c is equal to plus or minus 4t, where t is equal to m plus n. This is belongs to an integer. M plus n belongs to an integer. Therefore, again this equation can be written as modulus of a minus c is equal to 4t, where t belongs to z, because here we wrote here t belongs to z. Okay, how do you write this equation? How do you write the relation between a and c? Ordered pair a comma c belongs to R. Okay, my dear children. Here we observe that if ordered pair a comma b belongs to R and ordered pair b comma c belongs to R, implies that ordered pair a comma c also belongs to R for all a comma b comma c belongs to A. Okay, this implies that the given relation R is satisfying the transitive relation. Therefore, we can say that R is a transitive relation. See here, this is the definition of a transitive relation. Okay, my dear children. So here, relation R is reflexive. We proved here. It is a symmetric relation also and a transitive relation also. So finally, we can conclude that relation R is an equivalence relation. Understood, my dear children? How to prove a relation R is an equivalence relation? Okay.